Good morning, grade 12s. Today we're going to be starting a new topic for geography, and it will be focusing on maps. What are maps, the significance, and what the different symbols that are shown on a map represent in real life. So let's get started. What is a map and what is its function? A map represents the Earth in reality. It also shows the area and position by the lines of latitude. We will mainly be dealing with a topographic map this term, mainly because it is based on map work. But we have two types of maps, which is an orthophoto as well as a topographic. So let's get tuned into the content of a topographic map. So what is a topographic map? It shows the shape and height of land using symbols and colors. It also uses contour lines to show elevation. What are contour lines and what are their functions and what do their features represent? So contour lines are imaginary lines connecting places of the same height above sea level. Its function it is to show height and shape of the land. We also come across a contour interval, which its terminology describes that it is the difference in height between two consecutive contour lines. So contour lines can be seen or shown in the map in the color of black or brown. The most important features that we come across, which are needed mostly when it's time to calculate the map work, are mainly the spot height, which is the exact height of a location, a trig beacon, which is found on top of a hill, and a compass rose, which shows the north direction.
Moving to calculations. So here we're going to start by calculating the area. So the question says, refer to the demarcated area in red on the map. Calculates area of the orthophoto map in kilometers squared. Okay, so this is the demarcated area on this map. So we're gonna start by looking at the formula of an area. So the formula says length times the scale of a map. Okay, let us put it in brackets. Times breadth times the scale of a map times the scale. Okay, fine. Moving to the map. So now we know the formula of calculating the area. So now we are moving to the map. Now we are going to measure the length and the breadth. Okay, so the length 12.5. Okay, length is 12.5. A breadth the breadth is 11. So now we know the length and we know the breadth, but we don't know the scale of a map. So this map scale is 1:50,000. Remember the question said we need to calculate the area in kilometers squared. So this scale is not in kilometers, it is in centimeters. So we have to convert this 50,000 to centimeters. So when you are converting the centimeters to kilometers, we divide. So as you remember that when you are converting the centimeters to kilometers, we divide by 100,000. So we're gonna say 50,000 divided by 100,000. Okay, where is my calculator? Okay, it's 0.5. Okay, now we know the scale. Okay, now moving back to the formula. So the formula said length times scale times breadth times scale. So we're gonna say 12 0,5 times 0,5 times our breadth is 11, so times 11 times 0,5, which is our scale. So let us find what's the answer. Okay, it's 6,25. Very good. Times what's 11, times 0,5?
5,5.
Yes, it's 5,5. So here we say 6,25 times 5,5. Okay. Let us find out what's an answer. 34,3. Yes, it's 34,3 kilometer square. Yes, this is our final answer. Do not just leave your answer like this, like 34,3, but also include this, because remember the question said we need to calculate it in kilometers squared. So you have to indicate that this is 34,3 kilometers squared.
We'll be doing gradient. So the gradient determines how the slope it is. It's either it is gentle or steep. It says calculate the gradient between the spot height in A1, which is 2,136, and Trick Beacon in B3, which is 1,447. We have a formula for gradient, which is G is equal to H divided by D. D is for the distance and H is for the height. Okay, the first step is to calculate the height between the two. So as here we have 1,447 and 2,137. The lowest number to the biggest number, of which is 2,136 minus 1,447,9. So what is the answer? Yes, the answer is 688,1, which is in meters. Okay, step 2, we are measuring the distance from the spot height to this Trick Beacon, which is 19,2. So as we are using the topographic map, meaning that the scale that we are going to use at 50,000, but we are using the meters, so we're going to use 500, which is 9,600. Our step number 3, we're going to take these two answers and make them the ratio, which is 6,800,1 is to 9,600. Okay, after doing this, so we have this rule of what you do on the left, on the left, you also do into the right. So which is our step number 4. 6. Yes. So can you please tell me what is the answer? Or here, because we have the same numbers, it's going to cancel each other, which making it 1. And what is 9,600 minus 688? 13,9. Because we have a 9 and the gradient is always in whole numbers, so the answer is going to be 1 is to 14. Okay, when the gradient is like this, which means that the slope here is very steep.
Now let us determine the true bearing. So our question may be determine true bearing from the trig station on B3 to B4. This from is very important when calculating the true bearing. So we're going to calculate the true bearing from this trig station, of which they said it's B3 to B4. Then you place your ruler. Remember, we are going to start here. They said from the trig station on B3. Then you place your ruler and draw the perpendicular line that will cross this trig station, and then you join your points. Make sure that the line crosses this spot height for accuracy. Then after, you take your protractor. It is important to know how to place your protractor. Then you're going to this point on the protractor. Make sure it is straight on this trig station. Then U0 must be on the node. Then you have to move on a clockwise direction. And also make sure or keep in mind that the answer that you're going to get if you are moving clockwise, it is going to be less than 180 degrees. Anything greater than that is wrong. Then if maybe the spot height was on the left, the answer that you have to get is going to be greater than 108, but not greater than 360 degrees when you have to calculate on the spot height that is on the left side. Then here, let us continue. Our question was saying determine the true bearing from the determine the true bearing from the trig station on B3 to B4. Then we've already drawn our lines. Then let us put our protractor. Remember, the 0 must be on the node. Then we're placing our protractor here. Then we start counting. Remember, you move clockwise. Then you move, and then we reach where our point is. Then our trig beacon is 85,04. Our trig beacon, our true bearing is going to be 85,04 degrees.
So moving forward, we're going to be talking about direction. Direction is one of the most important thing you can learn from a map. We use direction daily. For example, when directing someone from the auditorium to LT12, we may not use the north, south, east, west, but we use words like left and right. So when we speak of direction, we also consider parts like intermediate direction, which is the northeast, northwest, southeast, and the southeast. Here is a question that we're going to do. Determine the direction from the trig beacon 275, which is here, to T at D5. Here the T is here and the trig beacon is here. We are going to determine the direction from the trig beacon to T. So what we must consider is that they mentioned that we are starting from the trig beacon to the D5, which means we are going to start here at the trig beacon to the T. So we are going to place a ruler at the trig beacon. This is a trick. You will draw a line starting from the north to the south, and then you also draw a line here from the west to the east, and also draw a line starting from the trig beacon to the T. So we know that this T is in between the east and the south. So by seeing this, we know that the trig beacon is located at southeast. If the T was here, we were going to say northeast. But in this case, the T is located between the east and the south. We are going to say the direction from the trig beacon to the T, it is southeast. we're going to talking about coordinates. What are coordinates? Coordinates are a set of numbers that indicates the exact position of a point in any point of the world. They are always given as latitude and longitude. Every single point in the earth have a unique coordinate. You cannot find a 2 points with the same coordinate. The latitude, which is this line, always indicates the north and the south. The longitude always indicates the direction from the west and the east. Latitude and longitude are measured in degrees, minutes, and seconds. So, in this case, this 30 degree, which is representing the latitude line, the 30 degree, it is degrees, and then this stroke represents minutes. So when in seconds, it's going to be 2 strokes. Line on a latitude and a longitude represents minutes, meaning that these lines represent minutes on the longitude and these lines represent minutes on a latitude. So in this case, we know that this 30 degrees 25 minutes represents the latitude line. So when we move from here, going down, the minute increases. So when we're going south, the minutes increases. Meaning here, since it is 25 minutes, here it's going to be 26 minutes, 27 minutes, 28 minutes. And then on the longitude, when we're going east, the minutes increases, which means when it's 15 here it's going to be 16, 17, 18. In a degree, there's always 60 minutes. In a minute, there's always 60 seconds. So the question is, how do we calculate minutes? Usually, we are always given the degrees and the minutes. So let us consider this place here. Maybe they are going to say, calculate the seconds in this point. So what you're going to do, the most important thing to do is to first measure the block. You measure the block, or I'm going to use millimeters. We're going to measure the block, focus on the latitude, which is the south. The latitude line, which is this line. So we're going to measure it using millimeters. We're going to measure the whole block, and we have 70 millimeters. 70 millimeters, and we're going to measure from the left to the point in a latitude way, and we get what? 30 millimeters. 30 millimeters. So what you're going to do here, we're going to say 30 over the whole distance, which is what? 70 millimeters times 60 seconds. Let us first punch this in a calculator. 30 divided by 70, which is 0.4. So 0.4 times 60 seconds. 0.4 times 60, which is 24 seconds. We know that the seconds from here, latitudinally, it is 24 seconds. So we're going to say 30 degrees latitude, which is here, 25 degrees, which is here, and then we have our minutes, which is 24 minutes. So now we're going to calculate the longitudinal part. We're going to do the same thing. We're going to measure the whole block in the latitude line. We also find 70 millimeters, and then we're going to measure from the north to the point, which is 35 millimeters. We're going to do the same process from here. We're going to say 35 divided by 70, times 60 seconds. Let us punch this in a calculator. 35 divided by 70, which is 0.5. 0.5 times 60 seconds is equal to 0.5 times 60 seconds is equal to 30 seconds. We know that the seconds longitudinally from this point to here, it is 30 seconds. So our answer is going to be 25 degrees, 15 minutes, and 30 seconds. Since we know the seconds from the latitude and the second from the longitude, we're going to write our total answer. Do not forget to include the direction. It is 30 degrees, 25 minutes, 24 seconds south, and 25 degrees, 15 minutes, 30 seconds east. This is our final